So the very first thing that we're looking at with numbers is understanding prime numbers. And so prime numbers are one of the most important aspects of mathematics. And the reason why they're important is because they break every number down into the simplest form, almost like an atom. But see, as we talk about mathematics, I think of in the beginning, God created the heavens and the earth, Genesis 1:1. And right from the beginning in the Bible, numbers are happening. We start learning about, the age of people, the chronology. There's a lot of pieces that come in right away in the Bible when it comes to numbers and how they're used. But the thing about numbers is that there's a lot of beauty in number theory in mathematics that we don't teach our students, especially in elementary school. So some of them grow up not realizing how beautiful math is. Let me go back and talk about the quadrivium for a second. We have the trivium and the quadrivium. For those who are on the call who might not be familiar with the trivium and the quadrivium, the trivium is talking about grammar, logic, and rhetoric. Grammar, we're getting a lot of facts. Elementary school years, there's a lot of facts and details. We have logic. People are beginning to ask why. And then we have rhetoric. People are able to defend what they're saying or explain or try to persuade. However, there is another thing we need to keep in mind when it comes to mathematics. I mean, when it comes to the liberal arts and classical education, which is the quadrivium. In the quadrivium, we have arithmetic, astronomy, geometry, and music. Do you know that all these are connected, right? All these are connected. And unfortunately, in education, sometimes we're breaking things down. There's fragmentation. So people are not able to really understand, the applications and the relevance of what they're learning. But let me give you a practical example, and then we'll come back to prime numbers and talk about prime numbers and why they're so cool. Um, do you know that the same mathematics that is used to explain CT scanners at hospitals actually is also connected to music? The guy who did the work, Joseph Fourier, for that mathematics, some of that mathematics can be seen in action for music. And so when we look at the mathematics that is happening in physics, and we notice that it's also connected to music, we begin to realize, wait a second, math, physics, music, astronomy, geometry, they're all connected, right? All these things are connected. And one of my goals in this presentation and generally in life is to focus on teaching parents how can you prepare your children to have an integrative approach to learning, not a disjointed and fragmented approach, but an integrated approach to learning. So let's start with prime numbers, as I said. Now, prime numbers they were talked about by a man named Euclid. Euclid wrote a book on geometry. He's famous for his work in geometry called The Elements of Geometry. And Euclid, his book is one that I recommend that every house should have. If you don't own Euclid's Elements of Geometry, let me know. We're going to have to get a bundle sent to Abuja because everybody should own Euclid's book. Why? Because Euclid was one of the people who laid the foundation for geometric reasoning and logic in one book. He brought it together. Now, Euclid lived around the time of Aristotle. Aristotle was a student of Plato, and Plato was a student of Socrates. And so logic was a very important element of what they were doing back then in ancient Greece. And so he said in his book, in the Elements, he talked about these prime numbers. And prime numbers are numbers that cannot be divided by anything else except by themselves and one. They're natural numbers. What are natural numbers? Natural numbers are numbers like your age. You never meet someone who says, I'm 0 years old, or I'm -5 years old. Nobody says that, right? Those are integers. Natural numbers start from 1 and above. However, 1 is neither prime, it's neither prime nor composite. A composite number is a number that is made up of other numbers. That's what a composite number is. A prime number is a number that once you reach that number, you can't do anything else. Let me give you an example of why this matters, actually. Let me see if it'll let us go back here. Okay, I was going to show you, if you take everybody on this call, take the number 28. If you take the number 28, is that prime or composite? We would say it's composite. But can we break it down to the prime numbers that make up 28? That is part of where this idea of breaking numbers down comes from. So that leads us to another interesting mathematician. So everybody, the first mathematician for the day was Euclid. Actually, the first mathematician. So God created the world. And humans have been thinking mathematically right from the beginning. People use mathematics to count their cattle, to count their sheep. There's all these things that happens with mathematics. But mathematics also has a side to it where you don't have to have the applications yet. You can just appreciate its beauty. And so one of the things that becomes very important is when we look at mathematics, we need to realize that there's applied mathematics and pure mathematics. Pure mathematics deals with the idea of math that doesn't have any application at the moment. But let me tell you two quick stories, and then I'll actually allow us to have any questions, thoughts, comments, objections before we dive into other beautiful types of numbers. Do you know that when we were doing work with prime numbers back in the day, there was no application for it at the time? But today, whenever you use a debit card or a credit card, do you know that prime numbers are used for securing those details in encryption, network security, and encryption? So when we discovered and started using prime numbers, we didn't have a use for it, quote unquote. But today we use it a lot. So sometimes, here's where classical education and mathematics meet. Sometimes in mathematics, it's not about the topic that you're learning. It's about the application. It's about the perseverance. And when you persevere and you build character, that can come out later on. I mean, how cool would it be if this was very often in math classes where we would tell the students, hey, students, what you're learning now doesn't have an application. You might not think it has an application, but it's building your character for what is to come. That is part of what mathematics can do, is that it can become this tool for building character, for building perseverance. That is part of how I view mathematical instruction. I'm not so focused on just teaching you something and telling you that it's going to be used tomorrow somewhere in your life. I'm also trying to teach you how to understand that your mind is being molded. You're being formed. There's something happening, and mathematics and numbers can be used as a means for that. So that was the first quick thing I was going to say, is that prime numbers are now used in encryption and so on. But then there's this idea called the fundamental theorem of arithmetic. The fundamental theorem of arithmetic is basically saying that a number like 28 can be written as the multiple of the primes, 2 times 2 times 7. Who came up with this idea? Well, there's a mathematician by the name of Carl Friedrich Gauss. Carl Friedrich Gauss. Carl Friedrich Gauss is known as one of the most impressive mathematicians in the history of math. If you look at the top 3 mathematicians the world has ever known, actually, first of all, maybe I'll let you guys have a chance to share on this because it'd be fun to know what you think or who you think are the best mathematicians. But Carl Friedrich Gauss is one of them. So I've already given you one answer. But I want to hear if anyone could, maybe if we could share 3 or 4. When they say who is the best mathematician ever, what names come to mind? If you guys don't mind, let's take a few names. So Pythagoras, that's a good one. He was good. He was good. Pythagoras was really interesting. Let's talk about him. Do you know that he was a contemporary of Daniel in the Bible? Have you ever thought about the context of Pythagoras and Daniel living in the same time?
No, I never. That's my first time hearing about that.
But okay, this is gonna blow your mind. Where did the Greeks learn their math from?
I don't know.
Babylon. Who was in Babylon as captives?
Daniel.
So could it be that Daniel and his people were actually partly those who influenced some of the work of later mathematicians? Remember, they were the best. Daniel and his friends, right? I'm about to read the book of Daniel, and this is, I've read it a few times. I'm going to read it again. I mean, these are very interesting times, so I'm really trying to pay attention, especially when I get to the second half as well. But the first half of Daniel is fascinating, and we learn that they were very good academically. So the Greeks, think about it. Pythagoras lived around 500 BC, but the Babylonians were the empire prior to them. The empires that control the time sometimes control the top scientists and mathematicians. Isn't that crazy? The empires that control the time control some of the top scientists and mathematicians. So Pythagoras, I think, was good. He got in trouble because he believed in irrational numbers. I don't know if you guys know that, but that's another topic we'll talk about soon. Thank you for sharing about Pythagoras. Anyone else have who would you say is some of the best mathematicians the world has ever had?
Newton.
Oh, yes. Yes. Newton is the other. Remember, I said there was top three mathematicians, right? So one of them is Gauss, one of them is Newton. Now, here's where it gets crazy. How many people know the third one whose name was Euler? Let's just be honest, if you don't mind, just how many of you know the name Euler or Euler?
I do, I do.
Perfect.
No, I don't.
Okay. Are you
I
ready for
think I
breaking? Oh, go ahead.
said I don't think I do.
Okay, well, here's the breaking news. The best mathematician the world has ever had in terms of proliferation of information and theories was a man named Leonhard Euler. You're going to hear about him later on. And do you know that Euler loved truth? Euler was a Christian man. He loved truth. His father wanted him to become a pastor, but he loved mathematics as well. And so he ended up going into mathematics. And but he kept writing in a way that you recognized that he was a diligent student of the Bible as well. When Euler died, he left. He published so much writings that we're still trying to package some of his writings till today. He died in 1783. Why am I bringing up the best mathematicians in this discussion? Because how do we teach students to think in a unique way about mathematics without telling them who the best mathematicians ever to live were? Again, this is not to bring anyone down, please. I'm not trying to make you feel sad if you don't know Euler. The point I'm trying to make, though, is in our education system globally, why are we not talking about Euler and Gauss and Newton more? Newton gets to be talked about in schools. They hear about him in physics. But what about Euler? And so we have a lot of students who think that math is boring or math doesn't apply to their lives when Gauss, the man who came up with the fundamental theorem of arithmetic, Gauss, when he had to go find money and the little money he had, guess what he wanted to do with that money? He wanted to buy Euler's book so he could read Euler's book. How crazy is that? That he wanted to gather his money around 1790 and 1800. He was trying to get money to go buy Euler's book. What if our students start getting so passionate about mathematics that they are looking for money to go buy a book? That would be fascinating and amazing. And we'll be talking about that a little bit more later. There's a lot to be talked about here. Primes continue to fascinate mathematicians today. As I said, they're used in many applications. There's the Greek mathematicians prove that there are infinitely many primes. It's a truth that has been established over 2,000 years ago that still inspires wonder today. Like just studying prime numbers makes you think, there's something weird about all of this. There's something called the Riemann hypothesis. It has not been solved yet. I'm hoping that someone from Nigeria will solve it, or someone from Africa, and we could talk about that later. So numbers are beautiful. Prime numbers are wonderful. So something so simple to define, yet so complex that it has brought many different aspects of mathematics into the discussion. Perfect numbers. I love perfect numbers. You see, when you look at numbers and how they behave, you begin to notice that there's an abstract part of our universe. See, for someone to say that this universe is a material universe, and that's all that there is, they're going to have some serious challenges. And one of the things is, we'll talk about the philosophical implications later if that comes up. But perfect numbers, let's dive into perfect numbers now. They are numbers that if you take them and you break them to their factors, you get them to add up to the number. So everybody see what the first perfect number is? It's called 6. So 1 plus 2 plus 3, those numbers add up to 6. 6 is called a perfect number. 28 is a perfect number. 496 is a perfect number. And 8128 is a perfect number. But in order to find perfect numbers, we need to know what the prime numbers within it are, right? That's one of the ways to begin to extract it. So this is the other type of numbers, just beautiful, that we see are perfect numbers. Before I go on, I want to mention one other thing about numbers that is pretty cool, called the Fibonacci sequence. The Fibonacci sequence is a sequence that is named after an Italian mathematician. And Fibonacci sequence is seen in nature. We see the Fibonacci sequence in the back of snails. We see it with sunflower seeds. So imagine you're looking at things. We even see it in the universe and the galaxy, the solar system, our universe. If you notice a spiral is following a certain equation, you begin to wonder, is there something more to this world? Like, is there something more? And that's where Romans chapter 1 comes in, right? God's invisible, his attributes are seen by the things that are made. So perfect numbers are very rare. And believe it or not, Euclid and Euler actually both did work with this. And so we have the ones I told you, the first one, the second one, the third one, but it starts getting more interesting as you move to find the next perfect number. We only know 52 of them so far, and they're all even numbers. So we've never found an odd number that is a perfect number. This remains to be an unsolved problem. Now, there's something called the Mersenne primes. Again, we're not going to go into the mathematics, sort of doing equations on the board. But if you guys don't mind, and if Brother Daniel gives me a chance, someday we should just do math problems, for 30 minutes for fun, if you want, and answer homeschool, classical school, any type of questions you might have for mathematics. Part of my background involves teaching mathematics and writing mathematics. And so I have curriculum that I give and support families with. One of them is called Counting to Calculus. And he told me to mention this part briefly, but our Counting to Calculus math program is connected to a program we started on Monday called STEM Clubs Across Africa. And the vision for STEM Clubs Across Africa is we want to redeem mathematics and science. So think about the classical tradition. In history and English, it's integrated for the most part. You're learning about something going on. You learn the history of it, and then there's the English side of it. But imagine if we could integrate math and science history into one course. That's how we teach at Counting to Calculus. So I would love to see as many families as possible use these tools, which were inspired partly by Isaac Newton's work. So I've been to Isaac Newton's house, and I'm going back next year. You're all invited if you would like to come. God willing. Well, you have to get there, but I would love to have us all there. I'm writing a letter to British Airways to ask for a grant or something to support educators and families who want to come from Nigeria and other parts of Africa. But why are we going to Newton's house, right? Part of it is we still have his notebooks. We still have some of his things there. But the other side of it is we are learning how Newton learned so that we can raise children to think like Isaac Newton. Ultimately, we want them to grow in truth. But what I'm saying is when it comes to math and science, that is one of the greatest minds the world has ever had. So why don't we give children a chance to learn from the works that he did in physics and calculus? Okay, so we have Euclid. I apologize, the box got in front of the name. There's Euclid, that's the first name. There's a man named Pierre de Fermat. He influenced the work of Isaac Newton. And then look at the third name on that, Leonhard Euler. Euler is the Swiss mathematician and is the most prolific writer of math in the history of mathematics. He made groundbreaking discoveries in many fields. Now, my prayer and hope is that we can raise the next generation of Eulers and Newtons right out of Africa. Remember the name I mentioned earlier was Gauss. That's how we spell Gauss. He was called the Prince of Mathematics. And it's just so interesting that Gauss read Euler. Gauss read Euler's book, and look what Gauss did. But how many students have read Euler's book today? I have a copy in a PDF form. You can feel free to just maybe give me your email, or if you want me to send you a link to it, or you can just find it called Elements of Algebra by Leonhard Euler. There's an Indian mathematician I have to bring up as we talk about the wonders of numbers. And there's a reason. In a second, I'll do that. His name was Srinivasa Ramanujan. Srinivasa Ramanujan is a very strange man in the sense that he did not get a technical math education in the traditional way that other people did. And he just happened to love math, and then he started doing math, a lot of it. And his story is very interesting because when he started sharing some of his writings, somebody told him, have you considered going to Cambridge University to share what you're doing? Now, if you don't know, Cambridge University is where Isaac Newton also went. And it is one of the best places to study mathematics in the world. The man, Ramanujan, wrote a letter to Cambridge and basically said, will you give me a chance? Think about getting an email today from somebody from a random country telling you, would you be willing to accept me in, give me a chance? And it's just like, this could be treated as spam or like fake. However, imagine if, just imagine if you also attach your notes, and now the person who received what you sent realizes that you're a genius, that you're something else. That's what happened with Ramanujan. Because of the notes he had, the man who received it said, I want to meet this guy. I'm going to give him a chance. And so Ramanujan went to Cambridge. He did some work. And here's one of the comments they told him, or one of the paraphrases. They basically were like, you are like Euler. You love numbers for their own sake. You think that they're beautiful. And I'm just going to be honest with you all. That is exactly how I feel about numbers. I think they're beautiful. I love, the world that God has made with the symmetry and the design and studying the patterns in the world that God has made. That's also how my mind works. And I think that that is part of the key for raising your children to become top mathematicians and physicists. Again, with a solid base of classical education. But what I'm saying is the world needs more ethical physicists and people who understand, the reality more than just knowing physics by itself. And this is one of the ways you do that. Inspire your children to love patterns and inspire your children to explore patterns in numbers. Give them a list of numbers and ask them, do you see any patterns here? That is part of my early childhood days. I remember that I was always looking for just patterns. This is my favorite mathematician of all time, Leonhard Euler. Very productive in his work. And one of the most fascinating things about him is that he actually went blind in both eyes at some point in his life. Initially, he went blind in one eye and then the second eye. They said that he used to dictate his notes to people, like to his assistant, who was a tailor, and his assistant, the tailor, ended up becoming very good at mathematics. Isn't that interesting? Just by the dictation of his notes. He was a very good teacher, and I believe every classical school really needs to have Euler's Elements of Algebra in every algebra classroom, because they will be giving their kids a chance to interact with the beauty of numbers and the beauty of algebra that Euler talked about. Almost everywhere you turn, you see something about Euler, and I'll show you one of his formulas now in a second. He was born in 1707. He was born when Isaac Newton was already wrapping up his career and everything. So Newton was born in 1642. Euler was born in 1707. Gauss was born in 1777. The three greatest mathematicians who've ever lived were all born between 1650 and 1800. That is very interesting. Why don't we produce some of the caliber of mathematicians and physicists like those of old? The question or the comment you just made actually is very interesting. So let me answer that question. Why is Amos so passionate about mathematics? And let me go back to Euler. I think that for me, I'll give you an example of how math came, like how my mind for mathematical reasoning kind of worked. When I was in when I was in third grade, I started writing examples for my classmates in arithmetic, trying to show them how to basically do different kinds of math problems. And this was in third grade on Sunday afternoons. I mean, this is odd. Why is a third grader doing problems on Sunday afternoon to show his classmates? I honestly cannot answer that question fully, other than the fact that somewhere along the way, something was instilled and inspired. Like I was inspired to just focus on patterns. Now, my dad was an electrical engineer, so there's a pattern there. He's in Abuja, by the way, and I come to Abuja from time to time. And so I think that I might not be taking into account some of the unstated things that have influenced my life. And I need to go back and actually think about it. So what I'm saying is I've never really sat down to do an anatomy of my discovery of math as beautiful, but now I'm beginning to think I should. And in fourth or fifth grade, I want to give you one more quick example of how a physicist's mind works when they're in elementary school still. I looked at the clock and I realized, wait a second, every time the long hand is on a number, you multiply that number by 5. And every time the shorthand is close to the number, you could figure out what the time is that way. And I remember telling them at church, I used to attend a church called ECWA in Lagos. And I said, I think I figured out how the clock works. So it was literally by looking at it and seeing a pattern. My friends, pattern recognition is the key. When students begin to see patterns, that is what does it for them. One of my best friends from high school went to MIT for his master's, and I remember asking him, why could I not beat you in math in high school? You were always beating me out all the time and all our friends. You were always the best. And I asked him, tell me, what can we do? What could we have done better? And then he sent me a paper later about a man named Anders Ericsson. Anders Ericsson. I'll put it in the chat. Anders Ericsson wrote a book called Peak. Anders Ericsson. And in the book, the book is called Peak. And in the book, he talks about pattern recognition. He talks about different aspects of becoming a master at anything. And I bring all these up to say, my friend told me, Amos, the reason why I was able to stay number one for 6 years in high school, because he was the best in math for 6 consecutive years, is he said, I saw the patterns when the teacher started writing on the board. So once I saw the pattern, I was good to go. Like, all he needed to see was see the pattern. So we need to teach children from a young age to see patterns, to start making connections as they can with these concepts in mathematics. So of anybody in mathematics, I honestly believe that Euler, which, by the way, Euler in the Lutheran Church, there's a day called St. Euler Day. I mean, that's how serious Euler was, right, about his faith, that the church recognized him in that sense. I mean, the Lutheran Church gave him sort of a day to commemorate his life. Let me go back. By the way, the king of Germany and then the queen of Russia, they were all trying to fight for Euler because they wanted Euler that bad. Okay, let's see the next two things here. So he was, again, a man of faith. He had 13 children. Unfortunately, he lost several of them in early childhood. And so this was the time that Euler was growing up. So imagine you lose 8 children in early childhood. You go blind in both eyes. How are you still able to give us the best equation the world has ever seen, which is what we're going to see next? I could come back to Euler's life after if there's time, but I don't want to spend as much time there. Euler calculated things, including the orbit of like planets. I mean, this was fascinating. This equation that you're seeing, however, is the most beautiful equation in mathematics. It's called Euler's identity. I made a video about the proof of this. Again, if anybody wants any resources that I've talked about, feel free to just send a message and say the name of the resource you want. So like Euler's book, or if you want to see the video on Euler's proof, I left my email, amosthemathguy@gmail.com, in the chat. But it's really interesting to see that Euler's equation. Let's talk about this equation for a second, and you guys will see why some people, they say it as a joke, but it's actually very interesting. Euler's equation brings together 5 fundamental things in mathematics. It brings together E, which is a transcendental number, I, which is a transcendental number, which is an imaginary number, pi, which is a transcendental number. These 3 things should not mix, but Euler proved that if you take those 3 things, they actually equal -1. That, my friends, was unbelievable. That's part of what Euler did with his one of his equations, of many equations he gave us. If you've ever seen f of x notation, that came from Euler. Euler wrote a series of letters to somebody it was called Letters to a German Princess. And that was partly because, as I said, Euler was in Germany and Russia in his lifetime. Let me tell you another interesting thing about Euler before we jump to Ramanujan. Do you know that Euler was friends with Daniel Bernoulli? And Daniel Bernoulli's father was Euler's teacher. Do you know that Euler's classmate Daniel was the one who gave us Bernoulli's principle for how airplanes fly? You guys ever heard Bernoulli's principle? That was Euler's classmate, or one of his colleagues. And you were fascinated by Bernoulli's principle. It's amazing. But what if I told you that the guy who did that would look at Euler and consider Euler to be one of the best ever? So to think that the guy who gave us Bernoulli's principle looks at Euler and salutes Euler as one of the best tells you that. But again, why am I bringing him especially up? One more reason. Because Euler in his writings acknowledged the one who created all things. Euler acknowledged in his life that God was the one behind all, the world. And why that matters is because there are many scientists today that have bought into a lie that you don't need God in the discussions of science and mathematics. But it's like, what is the basis for why science and mathematics works in the first place? Notice that when I told you the story of Euler, I also talked about Germany and Russia. Now we start looking at what was going on in Germany and Russia in the 1700s. By the way, Handel's Young Messiah was happening when Euler was doing his mathematics. Now notice why classical education is beautiful. Because it brings together history, philosophy, math, science. How beautiful would that be if we can make this the platform for the whole world to follow? A platform that says we should stop teaching math and science from a disjointed perspective, disjointed from history. I'll give you one last example on that. In 1871, there was a war called the Franco-Prussian War. What happens after 1871 in history? Germany becomes a dominant force in science. France used to be a dominant force. Something changed after 1871. I bring this up to say we need to teach mathematics, the beauty in the numbers, the beauty in understanding how it connects to science and how it connects to history. That brings math to life when people see where everything comes together. I talked about Ramanujan earlier. He died at the age of 32, but people called him another Euler. But see, he's almost like a disciple of Euler from afar. That was what they said of him at Cambridge, because he also saw beauty in numbers. Ramanujan is known for many things as well in mathematics, and he died at the age of 32. There was another mathematician that died at the age of 39 named Blaise Pascal. He also saw the beauty in numbers. These stories can help your students to begin to love mathematics because they begin to see the people behind the mathematics. They don't just learn about the concepts, they learn about the people. I've talked about Euler's identity already earlier. I'm just going to go to the last few slides and then I'll take questions, thoughts, comments, objections. Ramanujan came from India. He met with G.H. Hardy. G.H. Hardy wrote a book called A Mathematician's Apology, which I'm going to put in the chat, A Mathematician's Apology by G.H. Hardy. I highly recommend that book as well. And then A Mathematician's Lament by Paul Lockhart. These are some books that just come to mind right away by Paul Lockhart. These books are great tools that every educator should consider reading. Why? Because they show us the beauty in mathematics. What is taught in many schools around the world, I'm sorry to say, is not mathematics. Because have you ever met someone who says they hate music or they hate art? No, you don't really see that, right? But math is connected to both. So why would you hate math? Because of the way it's taught. And I'm going to drop a little secret here on this call. Well, it's not a secret. It's general knowledge. But I'm going to say it here to you guys to be one of the first people in the whole world to hear this. Because of the things that artificial intelligence does in mathematics, which it can do mathematics problems fast because mathematics is used to build those models that people use. And there's a whole topic about AI we can talk about, the good, the bad, the ugly. AI is the most dangerous and somewhat beneficial at the same time tool the world has ever made. John Lennox, who I've had a chance to meet a few times, has written a book called 2084 by Dr. John Lennox. It's one of the best books addressing this topic. And I'm sorry, I know we're talking about numbers, but John Lennox is a mathematician as well, but he's written a book on AI that I think is worth reading. But the reason why I bring that up is because in a world where everybody has a lot of knowledge-based tools and everything, do we need to be forcing children to learn math at a pace that discourages them from flourishing? I don't think so. I think we need to help children learn math at their pace of mastery and not worry as much anymore. Why? Because they have access to a lot of tools. And if it means that, here's what I'm saying. I'm not saying give them the tools to use it so they don't learn. No, what I'm saying is in the past, we told everybody, you have to move at a certain pace. You have to do this class and then do this class. But what if we just slow down and ask the question, have you mastered this yet? If they haven't, can we help them master that first? That is the progression that children need. Mastery-based progression, not a grade-based learning model that forces children to move ahead when they're not ready. That's where children begin to hate math. But if they are learning it at the pace of their mastery, here's the good news. They can actually learn 3 years or 4 years of math in 1 year. That is very doable. The math program I've written has been written in such a way that some people actually learn 5 years of math in 1 year, but they are moving at the pace of their mastery. And if they move at the pace of their mastery and they only learn 100 topics or 1 year of math, that's okay. Why are we rushing? Where are we running to? The key should be that they're mastering what they're learning. Okay, let me just go to the end here and I'll come back. I'm going to go down because I want to make sure that there's time to come back. This is an example of a number situation with Ramanujan. When G.H. Hardy visited Ramanujan in the hospital, he mentioned that he had arrived in a taxi with the number 1729. Hardy remarked and said, "That's a rather dull number." Ramanujan immediately replied, "No, Hardy, it's a very interesting number." Why did he say this? Because here's what Ramanujan said. 1729 is the smallest number expressible as the sum of two cubes in two different ways. I'm like, this is crazy. How do you just think of that by looking at the number 1729? That was the kind of mind Ramanujan had. The cube of a number is when you take the number and multiply it by itself 3 times. And Ramanujan was able to figure out that you can do that in 2 different ways with numbers. Now, one of the things that is interesting is give your children an exercise. Ask them to find the squares of numbers. Give them an exercise to find the cubes of numbers. And then ask them this question: do you notice any pattern? Because they will notice patterns. And so these are little ways we can do this. So again, if there's another time to just do math problems, I'll be more than happy to do problems for fun. But I don't want to scare people away doing problems on a board if you didn't come ready to engage with a lot of math exercises. My marker is working now, actually. So let me do this. If you tell your children 1, 2, 3, 4, 5, 6, and then if you square it, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. If you notice the difference between 1 and 4 is 3, the difference between 4 and 9 is 5, the difference between 9 and 16 is 7, the difference 16 and 25 is 9. Are we noticing a pattern? Those numbers are changing by just adding 2, right? So you have a pattern. But then you can also do 5 minus 3 is 2, 7 minus 5 is 2, and so on and so forth. So the point is this: there's a pattern in what the next number is going to be. So what is 7 times 7? Even if I don't want to do the math, guess what? I just say, oh, it's just going to be 36 plus 13 is 49. So notice that I can predict the next number because I know the pattern. Knowing patterns will help us in many things in life. So let me begin to land the plane. I know we're in the top of the hour, so I want to make sure that if there's any questions, thoughts, comments, objections, they can be answered. But let me just make sure I don't have any pressing last second things, and then the floor is back to you. I mentioned this verse earlier, and I'll just end with this verse. It says that the heavens declared, well, actually, Psalm 91, the heavens declare the glory of God. The skies proclaim the work of his hands. For since the creation of the world, Romans 1:12, God's invisible qualities, his eternal power and divine nature has been clearly seen, being understood from what has been made. My friends, mathematics is beautiful, and I want every child to know that. My heart aches when I see children say, this is boring. Why am I doing this? We need to show them a different way. Math is beautiful. It's the most gettable subject. It's beautiful. And the problem sometimes is how we teach it. Let's change the story. And I believe that Africa has an opportunity, especially. Here's why I say that. Because, again, I don't know where you guys are at in studying all the stuff happening in the world right now. But what you will realize is that a lot of the fields like quantum computing and space tourism, which I know it's crazy. Some people are talking about space tourism when we don't have water in my village, which one of my goals is to build STEM schools in Africa that focus on solving the water problem. We have to get clean water all across my village and anywhere else, right? I want to see classical schools come on board by teaching us how to think philosophically. Classical educators, you guys have a key, and I want you to give us that key. You know how to think in a unique way. And this is one of my cries to classical schools and classical educators. The best mathematicians the world has ever known were all philosophers as well. Isn't that crazy? The best mathematicians the world has ever known were also all philosophers of a sort, all of them. Why aren't we teaching philosophy with math classes? Why aren't we teaching logic and philosophy and mathematics and the history of science and math combined? Well, by God's grace, that's what I've put together with the Counting to Calculus program. And I'll leave that in the chat. But there are free resources on our YouTube channel for Counting to Calculus. We want every family all across the world to learn mathematics and to be able to tell their children, math is beautiful. Okay, I'm going to stop. Questions, thoughts, comments, objections. Yes, I will share the slides as well.
Yeah, thank you, brother. I'm back, and all is well. Thank you, brother, for this very impactful presentation that you've made. Please, if you have any question, please, you can drop them in the chat box, or you can just speak up, and he's going to answer you. Thank you.
Hello, Amos. I do appreciate your sharing with us, and it's great to see your passion concerning mathematics. My question would be like, what do you think is how should we approach introducing mathematics to students, like young children? I'm not yet married, but I'm planning to marry, and classical education is something I might want to consider. So It's something that I'm thinking about because I'm a mathematician myself. So how would we introduce mathematics to children?
Thank you so much for your question. And first of all, let me tell us on the call again that in an era of abundant information, there is only one education system that actually can survive, and that is classical education. And the reason is this. I'm not just saying this because Brother Daniel paid me to say it. No, he didn't pay me to say this. I'm just telling you this. Here's why. Because AI is a very intense tool that many schools want to use and all of that. But the problem is that when AI does your homework for you, you're not learning to think. There is a generation of people who are not going to be able to think because they have tools to do it for them. That is very concerning. But the hope I see is that classical education is around. Why? Because classical education doesn't just teach you about what to think, it teaches you how to think. And that is the key ingredient in this age right now. It's always been the key, but it's even more so very important right now. So I just wanted to say that first. Thank you for your question there. Now let's bring it together. Classical education and mathematics. How do we help children? So what we've done in Counter to Calculus is our curriculum actually starts from preschool all the way to university level 3. So what we've done is we've said, why don't we take all the concepts that everybody needs to learn and put it in a comprehensive list? So now we have the list, right? It's about 900 topics. We know every topic everybody needs to learn. Now we put it in a systematic way so that the child, when they've learned how to add fractions, they move on to subtracting fractions. Then they move on to decimals. Then they move. You guys see what I'm saying? You move at a certain pace, not based on your grade level. Okay, I'm not angry at anybody, but Amos's voice rises with passion sometimes. The biggest mistake in math education today is to teach math by grade level. The biggest mistake in math education today is to teach math by grade level. And here's why it's a mistake. Because math is not a grade-based subject. Do you think Isaac Newton was learning math and sitting down going, okay, what do I need to do for 4th grade? Okay, 5th grade. No, Isaac Newton wanted to understand certain things, so he went from end to end. He went from end to end. And that's part of our program called Counting to Calculus. It's saying end to end. You give me someone who knows nothing about math today, and 247 days from today, they're doing calculus. That's the idea, is guide them along the way. So when you tell somebody they're doing primary 5 math, and I own all the books for the Nigerian curriculum and Singapore. So, well, I own all the Nigerian books, but then I have some Singapore and stuff. We do it that way because it's convenient for the most part. It's not because it's best. So mastery-based learning is necessary. So for when a child is young, just follow them at the pace that they can handle and introduce them to, patterns, show them games, puzzles, singing. All these things help. And then when they start learning mathematics or with pen and paper, we want to make sure that their curriculum is a very solid journey, because some curriculums are bouncing around all over the place. Some children lose interest because they're like, wait, I thought I learned fractions last year. Yeah, you got to learn it again. But I thought I learned it again. We have to rethink what we're doing in making sure that children know where they're headed. That's, again, the idea of counting to calculus. You want an end to end. And so that no matter where you are, you get back on track. So that's my recommendation, is start them young, number one. Number two, use patterns, use songs, shapes and hands manipulatives. We want them to be playing with these things. And then pattern recognition. And it's nice to meet another mathematician. Excited to talk more also later about more mathematics. Someone said, I would like to ask how I can adequately equip myself to be a classical educator. So that's a question Daniel, I know, can add into this. I know that you do some programs for training classical educators. But can I just add one thing, Brother Daniel? I'm actually doing a science and math education program. I'm doing a science and math education program that is focused on training educators to think about mathematics the way I discussed it, right? In the sense of a mastery-based progression. So being a classical educator is excellent, and Brother Daniel, feel free to share on that. But as far as being a math educator who teaches math classically, that's where I love to share about teaching the history of mathematics. So if you want a resource for the history of mathematics, I'm going to put it in the chat, and it's called Journey Through Genius. It does get into some theorems. So if you don't want to get into the theorems as well, I would recommend other tools, but that's one of the best tools for learning the history of mathematics. And then let me see another one, A Mathematician's Lament and A Mathematician's Apology. If you read those three books, your understanding of mathematics will become one that is very similar to raising the next Euler, if that makes sense. So I see there's a hand up.
Hello.
Hello?
Can you hear me?
Yes.
Yeah. Okay. I wanted to ask you. First of all, I thank you for your passion to mathematics. I want to ask you. Let me take an example. I'm still single, but let me imagine as a parent. I didn't study math, and even let me suppose that I will marry the women who didn't study math. Can it be possible to teach math for my kids if I didn't study mathematics and my wife didn't study so?
Would you believe that, thank you so much for your question and thanks for having me again. Would you believe that one of the best pieces of advice I can tell you right now is that the best math teachers are people who didn't study maths sometimes. That's where you find the best teachers sometimes. They just need to know the skills and the tools, but they just need to be inspirational and a guide to help the children learn the mathematics to get them going. Now, of course, when you get into upper level mathematics, you would want to see how you can partner with an organization like this one, or a group that has educators focused on mathematics. But it is very possible to become an exceptional mathematician or math teacher even if you didn't study mathematics. And I left a link in my in the chat called livingsensibly.org. The reason why I put it there, though, is because of my book. I have a book that I linked, a free book called Tools for Mastering Mathematics. I want to encourage you to please check out that book, because that book is what has sort of been a tool for me the last 10 years in my work in mathematics and math education. I've also written a series of workbooks. We can talk about that another time. But my point is, if you read Tools for Mastering Mathematics, I actually give the blueprint for how to raise the next best mathematicians by learning from the lives of Newton and Euler. And that's my recommendation. So study the lives of some of the best mathematicians, and then as your children are growing up, give them tools to begin to think like those mathematicians.
Thank you so much, Brother Amos. Very wonderful. So I think after the meeting, I'm going to add you to the WhatsApp group. We have about 230 something people across Africa in the WhatsApp group, so that all the resources you are sharing, they can also have access to them. Thank you so much for the time. I don't know if we have any other question.
Yes, I had one more question. Thank you again, Brother Amos. This has been so magnificent. I just wanted to know if you can summarize you offered, I think, 3 or 4 recommendations when it comes to mastering math. You said end to end, to know where you're headed when it comes to recognizing patterns, and then you also mentioned mastery-based profession, and I think there was a third one or maybe a fourth one as well. I was writing it down, but unfortunately I was like trying to jot it down so quickly that I think I missed maybe 1 or 2. Do you mind repeating those if you remember them?
No problem. Let me do this. Let me put it this way. And please remember that I use these names as almost like mentors to younger mathematicians, even though they're dead, right? Newton, Euler, Gauss. But imagine you asked me, and I'm sorry, I forgot to mention this earlier. I didn't do a quick intro on this part, but yeah, my wife and I live in Texas, and we have 7 children. So I'm on my way. In a sense, I'm close to Leonard Euler. You guys might see why, right? By God's grace, we both have a lot of children. But I would say this: my children have shown interest. We have one who's 13 all the way down to 2. And one wants to be an engineer. One wants to become something in medicine. One wants to just be with in the outdoors all day. So I'm also noticing that different, sort of things they love. But they all, by God's grace, are getting a solid base for mathematics. Whatever they want to do with their lives, that's fine. I just want to make sure that they have a solid base. So now let me answer your question like this. How do you raise the next best mathematician who's grounded in truth and sees the beauty, the truth and the beauty and all of that? Like, how do we raise those people? There is nobody right now in the world who owns that corner. Nobody in the world has a solid base for how to raise mathematicians from a classical education base for top mathematicians. This organization right now is positioned, I think, to have some of these lessons that they can pass on to students and schools. And by God's grace, again, we're going to start hearing from Newtons from Rwanda and Eulers from Nigeria, by God's grace, right? This is literally very possible. And that is one of my heart's cry. Because that Ramanujan I told you guys about earlier, he didn't have a formal education to get him to where he was supposed to go. He dropped out of school. He failed. He was poor. He didn't really have a lot of things. But here's the good news about mathematics. All you need to be exceptional in mathematics is pen and paper. And even if you don't have that, write on the ground. So you can still do math. And so now let me answer those questions. Number one, mastery-based progression. You have to teach mathematics on a mastery-based progression because math is always building on what the prerequisites are. So if I don't know fractions, guess what topic I need to go back and learn? Prime numbers. Did you know that prime numbers govern your understanding of fractions? I don't know if you've connected the two before, but you need prime numbers to do lowest common multiple to do fractions. See why the mastery-based progression matters, number one. Number two, we have to tell the history. We have to tell the stories. We have to tell the students the context that gave rise to the concepts. We have to tell them the context that gave rise to the concepts. That is critical. Number three, we have to integrate mathematics back into science. Like physics, Newton is the father of Newtonian physics, but he's also the co-founder of calculus. It's the same man, but we've broken them apart. That's not good. That's why students are sometimes struggling, is because they're learning things that are not connected back to the source that gave rise to that thing that they're learning. Number four, pattern recognition. We need to teach our children pattern recognition. The more solid your pattern recognition skills are, the better off you'll be. Number five, I didn't mention this earlier, but there's some things I call the C's. The C's at this moment. We need critical thinking. Well, we need to think clearly. We need to collaborate. We need to think creatively. Do you know mathematicians can be creative? If you guys don't mind, can I just talk about a math concept just for a second, and then I'll come back and be done? Is that okay? Can I just do that for 1 second? I didn't know if I'd... Oh, okay. Okay, so let me just tell you two quick things. I'm sorry, I don't know if people have to run. Let me just say this. Do you know there's a problem called Fermat's last theorem? So this part is just leading me into another conversation. Fermat's last theorem came around the time of Isaac Newton. Nobody could solve it till 1995 when a Cambridge guy solved it. He went to school in Princeton, but he's originally from Cambridge, I believe. That man solved it, and he showed the whole world. It is important for us to recognize that the problem was posited in the 1600s. It didn't get solved till 1995. It's called Fermat's last theorem. And it basically says that the Pythagoras theorem, a squared plus b squared is equal to c squared, will not work for any numbers greater than squares. So there are no numbers in the world where if you do a cubed plus b cubed will equal c cubed. That doesn't exist. And it doesn't exist for any numbers greater than squares. Everybody was scratching their heads because Fermat wrote it down and said, I think I have a proof, but I've run out of room in my notebook. And then he died. So everybody was like, how do you solve this? And so they thought that there was a proof. But many people believe today that Fermat didn't really have the proof. But because they believed there was a proof, it led many for years, hundreds of years, and they solved it. So this is just an inspirational story to kind of set the stage. One guy solves a problem called Fermat's last theorem. However, in mathematics, mathematicians can be very creative. This man, in order to solve this problem, had to come up with new methods for doing mathematical analysis, and that was how he ended up solving some of the problems. He also had to connect one guy's idea or one group's idea to another group's idea and try to merge all these together. You have to be creative. In Nigeria, we sometimes say you're in arts class, you be creative. Science students, you don't need to be creative. Where did we get that from? God created the world. The creator has then put in us a desire to create certain things. We have creativity, but that needs to be brought under the subjection of truth. Lastly, what I was going to say about mathematics, this is the part that gets a little technical. In mathematics, there's something called factoring polynomials. When you factor a polynomial, you're trying to take these digits or these values and you're trying to condense them and make them more compact. But do you know that in order to do that, sometimes you have to substitute a new variable to solve the problem and then bring it back to the beginning of what you're trying to do. So what I'm saying is this: think of a rocket. When a rocket is trying to launch, it needs something to boost it up, and then it detaches. We do that exact same thing in mathematics, just that we do it with ideas. Isn't that crazy? We take an idea, we put it into a different package, we allow the new package to do something for us, and then we detach it from the new package, and now it has brought us to where we were going. That is beautiful. When I factor polynomials or rational expressions, I'm just being honest, sometimes I cry because I'm like, that was beautiful. I didn't expect it to turn left or right. And then so if you're doing math problems and you're not saying this is beautiful, we really need to talk, because math is beautiful. So those are the 5 things I can summarize. I don't know if there's any more that I've thrown in there. I'll go back in my notes and I'll email you those.